Assalamualaikum and good morning. So we are from Group 7. My name is Haris Ibrahim Risham and I'm going to present abstract, introduction and objective. So for abstract, the aim of this experiment is to perform pressure calibration on a burden tube pressure gauge using a dead weight. This experiment is done by inserting piston into the cylinder and air bubbles inside is removed by rotating the piston. When piston is inserted in the cylinder, the pressure gauge deflects as the first reading. Then load weights are added slowly until total mass reach 5 kg. And then the procedures are repeated 3 times to get average results. So the theoretical and actual result must be compared and calculated the percentage of errors in this experiment in order to calibrate the gauge pressure. For the objective, first, the aim of this experiment is to calibrate the burden tube pressure gauge using dead weights. Second, to compare the experimental results with the theoretical values. For introduction, the burden tube is one of the equipment to measure pressure. Before any measurement system or equipment to be used, it is compulsory to calibrate the equipment so that the equipment can be just accurate as the working standard. To calibrate a measurement system, you have to compare its output with a standard known input. The burden pressure gauge has been one of the best yet the easiest equipment to measure pressure because it consists a curved tube of electrical cross-section which is close to one end. So when the pressure is applied to one of the tube will straighten outward and will push the pointer to a specific reading.
Assalamualaikum, my name is Shafiq and I will be present the theory and methodology. Burden gauge. The gauge comprises of a lean wall close finish tube which is oval in cross area. This tube is both through and point of almost 270 degrees along its long pivot. The open end of the tube is welded to an empty mounting piece which permits the pressurized liquid to reach the tube. This causes the weight from the source to be transmitted specifically to the interior of the burden tube. The connected weight causes the oval tube to end up rounder, since a round cross area has the most extreme range for a given circumference. Because it gets to be rounder, the burden tube tends to uncle, which causes its free conclusion to move. A framework of linkages and levers transmit this movement to the gauge needle, which move over the scale. Dead weight calibrator. In a race to get an exceptionally precise weight estimation, it is basic to frequently recalibrate the gauge. This is often since the tube tends to end up weaker with expanded utilized. The regular procedure is to apply a non-weight to the gauge employing a gadget called a dead weight calibrator. The normal calibration method is to stack the gauge for non-weight, employing a dead weight calibrator counting a fluid of non-particular gravity. Utilize water as the fluid. This dead weight tester uses a basic cylinder and cylinder arrangement to supply a source of pressurized fluid. Within the explorer will create distance better, stronger, much better result than oil, which is transmitted to the gauge. Since the genuine weight of the fluid can be effortlessly calculated, the esteem can be compared straightforwardly to the perceiving on the gauge over the total scale extent. The dead weight tester comprises of a round and hollow cylinder, which is free to move vertically in a near-fitting cylinder. Equation used: pressure equal to force per area. Methodology: apparatus, which is first burden tube pressure gauge, dead weight tester, and piston. Parameters: first, the apparatus was set up. Second, the test gauge reading was ensured to be 0. Then 1 kg piston was put into the burden tube pressure gauge. Third, air bubble inside the tube was removed by tilting and tapping the piston gently. Fourth, the first reading of pressure gauge was taken after the system was stabilized. Fifth, the initial weight of 0.5 kg was put on the piston. After the system stabilized, the second reading of pressure gauge was taken. Sixth, the weight on piston was increased by 0.5 kg mass increment. Every time with 0.5 kg weight added to the piston, the reading of pressure gauge was taken. 7. Step 5 to 6 were repeated until the maximum weight of 5 kg is applied to the gauge. After that, the weight is unloaded from the piston by decrement of 0.5 kg. Each time 0.5 kg weight unloaded from the piston, the reading was taken. 8. Step 2 until 7 were repeated for 3 times to get the average reading. 9. All the data were recorded in table. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafami bin Manazli. I'm from GROUP7. So today I'll present about Rodent tube pressure gauge for two parts, which is part result and discussion. So for result, we have two tables, which is for the table 1. For table 1 is loading. And the table 2 is unloading. So for the table 1, as we can see, the mass is added, increased by 0.5, and so when the mass is added, the actual pressure is also increased, which is the pressure exerted by total mass kPa also increased from 30.9 kPa to 185.5 kPa, while for the percentage error for the loading is decreasing from 35.3% to 13.7%, then it's up a little bit to 17%, then it goes down back to 13.7%. So this for loading, while for the unloading, same, the mass is added by 0.5. So while the mass is increases, same goes to actual pressure, which is the pressure exerted by total mass kPa is also increased from 30.9 kPa to 815.5 kPa, while for the percentage error for unloading is decreased from 35.3% to 0.6%, then is go up again to 13.7%. Next, for this discussion, we have the first one is percentage of relative error for the theoretical and measured experimental pressure gauge, pre-theoretical, pre-experimental. So A is a piston of known area is loaded by known weight force. Therefore, the theoretical pressure P theoretical in the cylinder is P theoretical is equal to F over A, force over A. Then for B, measured experimental pressure F measured can be obtained from the reading of Bourdon tube pressure gauge. So for the method calculation, the mass of piston is 1 kg. The cross-sectional area of piston is 3.1731 times 10 to the power negative 4 meter squared. So for the true pressure exerted by piston is mass times acceleration, which is force, over area, so is equal to 30.9 kilonewton per meter squared. While for the true pressure exerted by total mass is total weight plus piston times acceleration, gravitational acceleration divided by area, so we get 46.4 kilonewton per meter squared. So for average reading of calibrated pressure is equal to 30.3 kilonewton over meter squared. Next, for the percentage error, there's two different types. Which the first one is for loading. So the equation is measure value minus actual over actual value times 100. So we get 34.7%. While for the unloading, measure value minus actual value over actual value times 100. So we get 13%. Next, for the source of error and the method to minimize the error. So for the error, we have four type of error. The first one is perilous error can occur when we don't put our eyes is perpendicular to the scale of the measurement. So to minimize this error, we have to repeat the experiment at least 2 or 3 times so that we can ensure that the value that we obtain is accurate. And also we have to take the average value. Other than that, we can also take the reading by several people so that the reading or the value is accurate. Next, for the next area is when the weight is added, the dead weight pressure gauge calibrator respond slowly to change in pressure, which can cause friction to occur. So to minimize this error, we have to rotate the piston in order to remove air bubbles inside the cylinder tube and reduce the friction so that the more accurate pressure reading can obtain. Next error is when the experiment is uh, when the experiment is occur, there's still a bubble that not totally been removed from the cylinder and hose, so that we have to minimize the error. We have to ensure that there's no air bubble or air trap inside the tube. So for the last error is the apparatus is sensitive to the shock and vibration. So if we are conducting while we are conducting this experiment, if something accident that cause the table to shaking or something happen to the table, it can influence to the reading that can be defect. So the method to minimize this error is we have to carefully while loading or unloading the weight. And also we have to repeat by taking the reading for 3 times to get more accurate result. Next, for repeatability and accuracy of this equipment. So for the repeatability in the world of Burden tube pressure gauge is the same thing. It's means essentially the same thing. It's mean within the realm of flow meter or the others devices. It is a measure of how consistently the pressure gauge is in accurately repeating the same measurement if all the condition remain the same. For example, uh, if exposed to the same pressure and and temperature, uh, the gauge should show the same PSI, uh, while the pressure and temperature remain the same. Next, for the accuracy of the equipment, accuracy is similar to the repeatability, is a little more nuanced, yet equally and independently important in determining the quality of Gordon tube pressure gauge. The accuracy is measure of how effectively a pressure gauge is repeating the upscale reading on the downscale cycle if all the conditions remain the same. For example, while a pressure gauge may read correctly at zero, midpoint and full scale during the pressure up cycle, it may read too high at the midpoint check during the pressure down cycle while still correctly return to zero. So that's all for me. Thank you.
So for the conclusion, based on this experiment, we can conclude that burden gauge is one of the suitable instruments to measure the pressure, even though the readings are not accurate to the actual values. But the readings which we are recorded from the experiment are consistent and closer to the actual values, so that the errors cannot be corrected but can be avoided to minimum. So that's all from Group 7. Thank you.